Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 15, Liquids and Solids, Part 2. Here are our objectives for today's video. Pause here. So we talked a little bit last video about the impact of intermolecular forces on boiling points. We're just going to talk about some other physical properties that are affected by intermolecular forces. The first of which is vapor pressure. So vapor pressure is the pressure directly over the surface of a liquid that exists because of molecules at the surface of the liquid going into the gas phase. So if something has really high intermolecular forces, it's going to be really, really difficult for it to go into the gas phase. So you're going to have low vapor pressure. And then the opposite is also true. If you have very low intermolecular forces, it's very easy to go into the gas phase, and then you will have high vapor pressure. Pause here. So these are just two other properties that are affected by intermolecular forces. So surface tension, this is something that you've seen if you've ever tried to put a bunch of water on top of a penny. That is the tension or force on the surface of a liquid that's caused by the intermolecular forces of those liquid molecules. Water is an example of that. Water tends to bead up. This is due to high intermolecular forces of that liquid. And then viscosity is a little bit different. It's the tendency of a liquid to resist changes in motion. There are some other factors besides intermolecular forces to consider, but typically high intermolecular forces are going to lead to high viscosity. There are some exceptions there. We can talk about those, but usually something that is more viscous will have high intermolecular forces. Pause here. You don't need to write down the question. So this is a multiple choice question that was taken from the course description. This is a publicly available document that just contains a couple of practice problems for AP Chemistry. And then I'm just going to work through this problem with you. So it gives the picture. I'm looking at it. First thing I see is the 2,3-trifluoropentane has those three polar bonds, but nonane has a much longer chain. Take a brief look at the table. The first thing I see is that nonane's boiling point is higher and that their molar masses are about the same, but nonane's is a little bit higher. So then the question is asking us to explain why nonane has a higher boiling point. So that means it is not due to the dipole-dipole forces trifluoropentane. If that were the case, that would have the higher boiling point. So that is why I eliminate A as a choice. Well, A actually just doesn't make sense because we're not breaking bonds when we're boiling. That's why I eliminated B as a choice. So then I've narrowed it down to C and D. So the reason why I eliminate D is because, first off, that doesn't really explain the difference, but also that doesn't appear to be true. The carbon-carbon bond length is going to be the same, so the chains are not further apart. That is why C is the correct answer to this question. Pause here. So this is from the 2008 chemistry exam. So I'm going to start with benzene. So first thought, I just talked about benzene. I found it to be easier to do that way. Benzene, it's totally nonpolar, has only London dispersion forces. It's not going to be able to interact very strongly with water for that reason. Right, so even if you didn't recognize that pyridine could actually hydrogen bond with water, this is something I could draw out. I took a look at the scoring guidelines. You didn't actually even need to say that it hydrogen bonding, but you needed to discuss that there was a structural difference. That nitrogen atom forms a polar bond with a carbon surrounding it because nitrogen is super electronegative, so it has dipole-dipole forces. I'm just going to add in now that you could also say hydrogen bonding. So because its intermolecular forces are more similar to water, it's going to be able to dissolve in water. Similarly, a lot of the times when you see things that can hydrogen bond, for example, ethanol, those things will be able to dissolve in water. Great. Here are the practice problems for today's video. Thank you so much for watching and have a great night.